In the past, we used to search for information on the internet using traditional search engines. Today, many users interact directly with large language models, LLMs. A question is asked, a prompt, and we receive an answer in return. This concept is known as generative AI, artificial intelligence that produces content. But where do these answers actually come from? In traditional LLMs, they are based on training data from the past, often months or even years old. That's why RAG, Retrieval-Augmented Generation, was introduced. RAG enables even general purpose or small models to incorporate enterprise-specific and up-to-date information, allowing for tailored responses across different use cases. And here's how it works. Companies take their internal content, such as documentation, product data, or internal reports, and convert it into embeddings. Embeddings are mathematical representations that capture the meaning of this information. These embeddings are then stored in a vector database, a special type of database optimized for handling and searching such complex representations efficiently. When a question is submitted, it is also transformed into a vector. The vector database searches then for similar content, and the LLM uses this retrieved context to generate a relevant, up-to-date answer. We operate under the assumption that this data is correct, but what if exactly that data is manipulated? What if someone alters the context, and the model delivers misleading or even false answers as a result? That's exactly the kind of risk we address with Guardium in the following demo. We start with a working RAG pipeline. I'm using a local setup that includes a vector database Milvus and a lightweight LLM. The chat interface you see here communicates with a Python backend. So let's ask a simple question. Great, the answer comes directly from the vector database where we previously stored the official pricing data. Now let's simulate an internal data manipulation. Behind the scenes, that information is still sourced from a flat file CSV on a disk. Imagine a malicious insider or compromised application modifies this information. Next, the script loads that altered file back into Milvus, and no application level error is triggered. Let's go back and ask the same question again. And here is the result. This is a manipulated answer, and it shows how easily a downstream LLM could be misled. Now, the key question, how do we detect that this happened? Guardium was running in the background and captured the tampering in real time. In the Guardium console, we can now see two things side by side. Notice that while I simply saved a file, Guardium has already captured a write event on that CS file. At that point, no database call was made yet, but the change to the raw data is fully audited and could have already alerted security teams. And the exact insert and upsert statement that changed the vector record. Our dashboard report table also breaks down each command into key columns: time of execution, executing user, IP, action performed, and the target object for at-a-glance clarity. And if I would like to examine further, for instance, see what else this particular client did, I can run another query with just 2 mouse clicks. This gives security teams the ability to trace unauthorized changes from the file layer all the way to the database row, something traditional integrity checks can't do. Now let's switch gears a bit. In the previous step, we saw that unauthorized data tampering can be detected. Now let's go one step further and actually prevent it using a blocking policy. I'm now logging into the Milvus database using the graphical interface. Let's try to tamper with the pricing data again. for instance by deleting the entry. This action is blocked in real time by Guardium. Why? Because the policy I configure says that only privileged users might touch sensitive pricing data. Guardium intercepted this change attempt, blocked it before it could reach the database, and quarantine user without needing to modify the application logic or backend code. In Guardium, we can define policies such as allow application traffic at all times, allow changes only from specific accounts like data admin, deny changes during off hours, or trigger blocking when patterns like update on sensitive tables are detected from unknown clients. In this case, our blocking policy enforces least privilege, a core principle in modern data security. This simple demo shows how vulnerable an LLM pipeline can be when your vector database becomes a blind spot. Guardium helps organizations regain visibility, detect anomalies, and enforce security policies, even in modern AI-enhanced environments. Thank you for your time. If you would like to learn more about Guardium and explore how it could help to increase security level in your company, please feel free to contact me.